Hey, Google, connect to my Mac.
Okay, looking for paired devices. Bluetooth is connected to McCannon Foothill 545.
Hey, good morning. Good morning, guys. Thank you for coming. I'm sorry for the delay. I'm actually trying to get Zoom going on my iPad also, like Juan. I think I have to update the Safari app or something here. It's not doing SSO, signing up. If I connect with my iPad, then I won't have this problem with the small screen size because I can have the gallery showing on my iPad, and I can, have the full screen with the code. Let me see one more time, okay? Just give me 1 sec. Meetings. Is there a place where I can do SSO? Mirror. Oh, geez. Okay, I don't know. Maybe I should talk to Juan to see what he did, because it's certainly not letting me. Oh, sign in. Let me try sign in. Okay, sign in with SSO. Oh, it can't. It can't find the server. Okay, so there's some problem here. Safari cannot open the page because it can't find the server. But I'm online. So, all right, I will debug that later in my own time. Great. Well, welcome to class. I'm happy to see you all. Kate, yeah, welcome. You were absent last class, but hopefully, I hope you got a chance to watch the video and all and catch up, because today I'm thinking that what was it we were going to do? We were playing with arrays. We were playing with arrays last class, yes? And then I said, today let's try an array problem that involves numbers instead of strings, because last week we tried string arrays, arrays with lots of strings. It's all in the video, right? And I think who was Jose was coding. Where's Jose? Yeah, Jose was coding. I think Juan helped us with the tablet initially, but we won't have a tablet need today. We'll just do numbers, and this is going to be an interesting problem. I have a couple of problems. Well, we'll see which one you guys like. One of the things I was thinking about was, I mentioned it last class, is if you have a hey, Lingchen, you have two windows. Are you logged in two places? And both our cameras off, right? Lingchen?
Yeah, yes, sir. Yes, sir.
You have two devices logged in?
Yes, sir. I have a tablet with camera. I don't have a camera on my PC, so I use my tablet for the.
Oh, I see. All right. Oh, all right. Well, if you can switch on the camera on your device at all, that would be great. Yeah. Otherwise, I understand as long as you keep talking. So that's great. All right. Yeah. Hi, Lingchen, and Changwen too. She's probably getting her kids ready for school. Okay, so fantastic. So the two problems I was thinking of was, one of them I mentioned last class was trying to find the second biggest element in an array, not the maximum element, but the second max is the second biggest element. So the other is to histogram. How many of you know what a histogram is, right? I mean, if you're all going to be majoring in computer science or math-related fields, or any STEM-related field, you're going to be having to do science, right? You're going to have some science papers, and then in science, one of the basic kinds of measurements we take is a histogram. histogram is basically saying how many values fall in this range, how many values fall in this range, and so on. So you can essentially, you can histogram a number of things. You can say in this population, we want to histogram the number of people who got infected with COVID, for example, right, by age. So you can say 0 to 10 is age 0 to 10. This many people got infected. 10 to 19, right? 0 to 9, 10 to 19, that many people. You've seen charts like that, right? 0 to 10, 10 to 19, 9 and 20 to 29, and so on. It's all over the news, and people, not just COVID, anything that you can bin in boxes like this, you can see charts online. You go to news sites also, they say, break it down by bins, and say in each bin there's that many people or that many beans or certain things like that. Have you guys seen this? Have you seen charts like this? Okay, they're called histograms, and it's very useful for studying the trend of things. For example, if you want to know if something is uniformly distributed, equally likely, or some things are more likely in certain parts of the distribution, right? Because if you didn't, for example, if you take the COVID case that I outlined before, you could make an uninformed inference saying that, well, everybody in the city is equally likely to contract COVID, right? Based on national statistics or something like that. Yeah, that's one way of measuring things, and it's it's an inferior way than if you take that and break it down, right? So even within the place where there's a high incidence of COVID, if you break it down further by age group, right? We can see that 0 to 10, well, not so much, but 20 to 40 years of age, maximum COVID, right? So you can see the distribution, and you can see that, okay, that kind of curve, where so as the age group is 20 to 40, it's much higher, and so things like that. And it's very interesting, and we can do that, right? We can do that in class. We can generate random numbers and do that. So we have two of these things open in front of us, and my preference is that the second maximum, the problem to find the second maximum element in an array of numbers is a classic. I think it would qualify as an icebreaker interview problem, because I told you last class, right? Nobody's going to ask you to find the maximum or minimum. That's basic, high school programming level. So they may ask, how can you find the second minimum or the third minimum or the nth minimum in this array? And so rather than do that in class, I think it'll be nice. Hey, Lincoln, you can actually turn the laptop or your device around by 90 degrees, right? Yeah. Well, were you playing around with this before? Because you know how to do it. Yeah, okay, cool, no worries. Okay, so yeah, what was I saying? So that problem I would prefer if you do it on your own and post solutions in the forums. And they're all actually eligible for extra credit, by the way. Okay, so even those who are not in class and watching the video, you can code up a solution for finding out the third or second biggest element in an array, and share it on the subreddit. Okay, and if it's a cool enough solution, you may just get magic extra credit points added to your canvas. Okay, so sometimes you'll just get points added in your canvas column, and it won't be public. Nobody will know, but you'll know that you got extra credit for it. And so you will actually get cool extra credit, cool extra credit points for things like that. So maybe you can do that, or you can do the histogram thing on your own also and share that code. But if you don't, my preference would be we could do histogramming in class, because that's one thing I wanted to do for a long time. Because previously, when I was working out there, I needed to get a histogramming tool. Because if you're working in data science and machine learning, histogramming is essential. Okay, so you either you write someone else, you get someone else's code, or you're going to write your own, but you're going to have that from day one, because you're going to look at trends in data. Right. So if you're looking at terabytes of data, and you have to identify a pattern in it. Now, if you look at the data cold, it's very hard to find a pattern. Yes. However, you may have some intuition saying, well, you know what, I can't make any sense of this data, but let me now try and slice and dice this data to say, well, let me see if I can break it down by, let's say, age, okay? And then bin all the data points by age. Now, is there a pattern? Well, no pattern there either. Okay, now let me see if I can break it down by demographic, okay, or ethnicity, or disadvantaged populations. So you make these chunks, right, and look at the data in each of those chunks, and then if it's all uniform all over the place, then okay, the data doesn't have any biases. No matter which way you look at it, everybody's getting equal opportunities, okay? But if you bin it up and look at the thing, and sometimes if you have an intuition, correct intuition, right? If you don't have a correct intuition, you're not going to see a trend. And that is the reason why data engineers are so valuable. And I made this point in a previous quarter, also in computer science. Data engineering, machine learning, they are not computer science. They are empirical sciences, right? They're already one step removed from mathematics and computer science, which are pure sciences, because you're going after the absolute truth, right? When you find something and prove something in math or computer science, it's 100% true. There's no way it can be false, right? So there's a distinction between deductive truths and inductive truths, right? And inductive truth sometimes, is true most of the time, but you don't know. It could be wrong one day, right? So that's an inductive truth. And machine learning and data science, they're already gone from pure science. They're an empirical science, because now they're governed by what you observe, what you can measure, not what you can logically think and infer, but what you can measure and what the data says, right? So in other words, we have to be bound, when we are scientists, we have to be bound by the empirical world that you see out there, because science is ruled by the empirical world. Anything the empirical world is, says is true. If science has better account for it, or the theory is wrong, it has to go out the window, or you got to put a band-aid over it. Okay, so so data science, data engineering is basically a measuring science. And when you're doing measuring sciences and you're good at it, histogramming and looking at the data in different ways is like super duper important, because intuitions that bubble up in our head when you look at the data are what eventually become scientific theories, right? Because you think about it, any scientific theory, Newton or Einstein, as if you wanted to form a theory of gravitation, right? He can come up and, wake up one fine day and think, well, I'm really bored, and scratch his head and say, okay, I got a theory saying GMM over R squared. That's, that's the gravitational attractional force. He doesn't do it like that, right? What does he do? He will conduct, hundreds and thousands of experiments, right? He'll drop an apple, measure the time it takes from a different height, measure the time it takes. And of course, his measurement, especially in those days, for poor ass measuring instruments. So they got to measure like 50,000 times and take the average to say, okay, that's probably what the real measurement is, right? Because we're bound, our hands are bound by the accuracy of the measuring instruments when you're in empirical science. And so you take lots and lots of measurements, and at the end, no matter if you're a 17th century person or 5000 BC person, working on a pyramid or some ancient thing in Africa or China, right? You still have to bring that knowledge to bear about, I've done so many experiments, I know that this is what's going to happen, but let me look it up and look at all the different perspectives of the data, and now I can get a theory, right? Now, here is what distinguishes a data engineer, a good machine learning or a data engineer, from a bad, well, I shouldn't say bad, a less than good, right? Less than top data scientist or an engineer, is that the good ones are always inevitably good scientists. They would be good physicists, chemists, anything in the empirical sciences where you have to measure things and look at the data and say, well, you know what? I've looked at all these things, but it seems like the photon is always going in this, well, not always, 90% of the time, the photon is going towards this slit and not that slit. Well, right? So you may make these theories by looking at the data, because if you didn't look at the data, you have no idea, right? So, you say, this photon's going through slits, that's it, right? But if you look at the measurements and say, well, then you can come up with theories. But how do people know to say, well, I'm going to look at the photons going in this path in this particular perspective where I can chop it up, right? Because if you just take a look at random photons scattered in the sky, you're not going to discover any patterns. However, you say, well, you know what? I have a theory, and I have a gut feeling that photons will bend in a strong gravitational field, right? Isn't that one of Einstein's theory's predictions? right? Because if light passes near a star, it's going to bend because the star is going to attract the light. Light is energy and mass, and it's going to attract. Yes. Okay. So so that's the theory. But if Einstein didn't have the suspicion that it's going to bend near heavy objects, nobody would have even invested any time in trying to collect the information, right? They're saying, well, I want to collect the information about photon movement, and I'm going to put it in two different bins, right? This side are all the photons that pass near a heavy star. This side are photons that you're just passing through empty space, right? Now, if you make that kind of division, then you'd be able to see the divergence, right? Because if you didn't have that bin, all of the photons are pretty much the same. So you wouldn't see any distribution. Yes. However, if you say this side is a different kind of photon than that side, then you can see, wow, these photons are behaving differently from those photons. Then you have the inkling, the basic, the start, the seed of a scientific theory. So that is how a scientific theory starts. And then the scientists will come up with reasons, and not absolute reasons, because you don't know. Whenever you're dealing with an empirical science, you absolutely don't know the truth, right? Because the only things we know are what we can come up with in our heads with our intuitions and say, well, maybe that's true. Let me test it out. And then you take millions and millions of measurements and say, well, all of these measurements, they are consistent with what my brain came up with, right? My mind came up with this theory and everything is consistent. So you look at the data and form a theory and then verify that theory with more data. That is generally the progression of a scientific theory. So the people that are good machine learning and data science engineers, right? They need to know programming, obviously, because you're going to use programming. But the best ones are the ones who are also good scientists. So in other words, they have to have the scientific mindset. Now, the scientific mindset, in my experience, I found is not really something, just like math, the math mindset or any other mindset, is not something that will just can be thrust into you from the outside. Okay, you just have to look at lots and lots of scientific theories, look at the history of them, see how did they come up with it, right? How did they come up with this crazy ass theory, which I can't find intuitive at all, but everything in the world seems to obey that theory, right? Yes, think about it. If you even take the simple theory like gravitation, right? We're so used to things falling down, bam, 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 like that. Right? But however, if you say that there's these two objects in space and there's a mysterious force, right? You can't see a hand reaching out and grabbing that one, right? There's a mysterious force between those two. So it's magic, essentially. And postulating that, there was this magical force between two massive objects in space, which actually turns out to be wrong, but that was Newton's prediction, isn't it? Right? So, but that was Newton's prediction, and it's just a magical force. How did they come up with this theory? By looking at lots and lots of data. And therefore, those who are interested in machine learning and data science should pay attention, not just to the programming part, but they should pay great attention to all the other empirical science classes they're enrolled in: chemistry, physics, anything that requires measurement, observation, and taking notes, right? And measuring and making a table of data. You've got to be like super duper good at it, because, and the reason for that is because the most highly paid, payroll commanding data engineers, okay, who can basically sit on a beach and look at the data on their phone and say, well, that's probably what's going on. The next time I'm in, I'll tell those guys to test it out, right? So, and then they get, millions of dollars for coming up with these insights. So the most highly prized data engineers are the ones who can just look at data and form a good insight. And they, but how can you form a good insight if you don't know what data is generally shaped like, right? So that's why, the first step in forming a scientific hypothesis or a data engineering, a data pattern identification in machine learning is to basically just familiarize yourself with the data in the first place. So you got to be swimming in the data for several months, right? So you can't hire a data engineer and ask them to look at, hey, here's your terabytes of lakes and lakes of data. Come up with a theory tomorrow. Right? You say, tell me why the hell this is going wrong. Why aren't my customers buying this product? Here's our data. Never happens, right? So any CEO or a manager who says this to a data engineer has not got the faintest idea how data engineering and machine learning works. Okay, the way that these things work is that person should be immersed in the sea. They need to know how to swim, right? In a different lake, not in a, they got to be in the data and looking at the data in many different ways. Okay, and after a while, maybe it's 1 month, maybe it's 2 weeks, or maybe it's many months, right? then the insight starts to bubble up. Because and the way it bubbles up, you can't force it. Because the way it bubbles up is that in your mind, you're thinking about the data and saying, well, there's this pattern, I think, but it's got to be in there. Why can't I see it? Right? And so in your mind, subconsciously, when you think about that, your mind will generate lots and lots of theories. And in your mind, you'll play out the data distribution and say, well, that's not likely to be the case. That's not likely to be the case. But each time you say that's not likely to be the case, your mind has familiarized yourself with one perspective of the data. And so you look at the data from here, I can't see anything interesting, right? You look at the data from here, I can't see anything interesting. After a couple of months, you're looking at it from here, right? And that perspective gives you that, final picture. Everything falls into place, and you can say, wow, that is why everything is going on like this. Yes, and then you go to the board meeting and say, we found out, right? Nobody else can see this because it took 3 months of looking at the data to peer at it through this tiny tunnel, and that's where the answer is, right? And that is worth millions of dollars. So, so the way to be a good data engineer is basically just to stick yourself in the data, keep swimming in it, with no expectation of finding anything, but just letting your mind come up with lots and lots of theories, right? Just like a scientist, come up with lots and lots of theories. But scientists, a scientific theory, not like a supernatural theory where someone says, well, the sun goes around the earth because there's an invisible hand, right, doing this, and say, well, where's the invisible hand? No, you can't test it, you can't see it, and there's no observational evidence, but you still have to believe it, right? That's not a scientific theory. A scientific theory is something that can be tested. And you say, well, this is what's going on. And I say, why? Well, how can you say that's what's going on? Yeah, you can say, well, that's what's going on because you can do an experiment yourself and find out, right? I'm not here in the room. You can do it and find out yourself and convince yourself. That is a scientific theory. And the way to come up with these scientific theories is just to be breathing data in and out for a long time. So if you're not comfortable with breathing data for a long time, you can make your choice right now, saying, well, that's not data engineering and machine learning is not for me at this time in my life. Maybe I'll come back to it 10 years from now or 15 years from now. Maybe I'll go and use computer science for something else, right? Instead of data science and machine learning, I'm going to look at algorithm analysis, or there's millions of things you can do, right? In computer science, it doesn't have to be data, or even game development, right? So you can do game development. I'm sure a lot of people, how many of you have played Fortnite? Nobody? A few people, okay, right? So it's a really cool game, isn't it? It's a really cool game. It's done nicely. It's done with the Unreal Engine, which has got a C++ interface, right? It's a C++ interface, and they've designed it in such a way that your C++ code for Unreal is actually very easy to create, right? And you can even create some of this code visually by putting boxes like we're doing, like Uwan was doing last class, putting boxes and connecting up with lines. The the development kit will give you a free toolkit you can download from Unreal, where you can actually create code by drawing boxes and drawing lines between them, right? And then it'll translate that into C++, which you can go in and tweak more with your hands, right? All of that is free. So then again, and you can create, in fact, even better is that they even get you started off. You can go online and search for Unreal tutorials from Unreal itself, right? And there's so many tutorials. And I think one of the tutorials probably has you creating an island of your own, right? So they start you off with a basic island with nothing on it. And then you have to create artifacts on this island, right? You can place volcanoes, lakes, you can say where your parachute is going to land on that island. And then also the actions that will happen inside of those, all of that you can do, and you can create your own island. And then it's step-by-step walkthroughs on the, online and so on. So those are things that don't require data engineering, but just require some creative thinking about artistic ways of, creating a virtual world. So there's so many different ways you can exploit computer science. So, but I wanted to make sure that people know, right? A lot of people say, I'm going to do data engineering and machine learning, especially in CS2A. Lots of students, when I look at the introductions too, right? And it's okay. It's okay to do that, but you got to have a realistic expectation of what data engineering is before you get in there, right? So I don't want you guys to pick data engineering too soon in your life when you're learning C++. And then later on find out, well, I'm not really cut out for data engineering. Then you would have lost out a lot of time where you could have actually made some serious headway in game development or something else. So now is the time probably for you to think about what you want to do so that you can position your interests. And you should also know that just because you're saying, I'm not going to do machine learning and data engineering now in college, I'm never going to do it. No, that's never the case, right? Everybody will try everything. And you will try to do this, game development for a while, and you come back, and then you may do, data engineering at a later time in your life when your mind is more equipped for that. So, where I was going with that was that this histogramming thing will actually be very useful. And we can use this to when we code it today, we can use that to look at patterns in data, right? I'll show you how you can generate a whole bunch of random numbers, which you already know how to, and then look at patterns in the data, right? And say, is this truly random? Now let's take a different cut at it, right? Is that random? So it'll actually be a small, minor, it's a baby exercise. Let me put it this way. It's going to be a baby exercise in data learning, the data science and machine learning, okay? And so you have these two options. So you can pick which one you want to do today. And the one who, the person who picks up the code and we start coding, we will try and implement that, okay? So we can, so yeah, what would you guys like to do? Do you want to do, what was the first thing? Yeah, the minimum of, the minimum, the second minimum, it's not a big problem, okay? Even the other one is not a big problem. But finding the second minimum is so common, I think, right? It's out there, and you can Google and find out if you want. Well, or we can do it in class together. That's also okay. But I would rather that you Google and no, not even go use Google. Okay, you should not use Google. Try and find it on your own and share the code online, and then we can have some fun looking at the code together. And very few people are posting online. I just want to make sure that I do watch the Reddit posts. I get notifications. Within a few minutes of anyone making a post on Reddit, I get a notification on my phone, right? So even if I'm out there by the lake, I'm going to look at Reddit and see who posted what, okay? And it doesn't even, many times I don't even need to type in an answer, right? So I click the box and then I have autofill, the Reddit autofill will suggest, is it Reddit autofill? Maybe it's only Gmail. Right? Many times, if it's Gmail, right? I get a suggested response by the system, which most of the time is what I'm going to type. So I just say, send that response to the student. That's why you get many times you send me email during the day, you get an answer within 10 seconds or 15 seconds, right? So I can't even type it in 10 or 15 seconds, right? It's because I use the automated response that Google gives me, and most of the time it just fits the bill perfectly, right? So not only your Reddit posts, right? I basically have my finger on your pulse in the sense when you quest, okay? Every time anyone submits any code at all, I can tell within a couple of seconds, I can tell, right? This person submitted this quest at this time, and that's how many trophies they got, right? I get that every time. So I can see, and so over a period of a week, I can look back and say, well, that person has been questing regularly every day, and a couple of times at this time, and depending on the interval between the two tries, I know, right? They tried, something didn't work, they only got that many points. Then 3 hours later, they tried again, and they got those points. Then I know, right? It's not just those two submissions. Between then and then, they've been doing a lot of work. They've been testing it out on their own laptop without submitting, because I can tell, right? Because there's been a progression and there's 3 hour gap, and I get this on the phone, right? So so it doesn't matter where I am, right? The only time I can check this is if I'm actually driving a car, where so then I don't look at my phone. But if I'm walking or sitting down on a bench, I get these messages. So please let everybody know that I'm watching, and not with a view to policing things, but I'm watching with a view to finding out where people are stuck and whether it is a place where you're irretrievably stuck. Okay, if you're stuck in a place where I think you are unlikely to get help from your classmates and you're going to be stuck there for a very long time, then I'll come in, right? Or a tutor might say, Lane would say, well, that's how you can get past that place. But otherwise, we'll just see what you're doing, right? And then we're just going to be patient, especially if there's 5 more days for the quest to be submitted, right? So because any solution that is given to you is basically a piece of your knowledge that's been taken away from you. And people always think that when you ask a question and get an answer, you've got the answer in your head. That is actually the exact opposite of what happens. When someone gives you an answer, that answer has been taken away from you, right? It's as though you had the answer, you had the capacity to come up with the answer, but that someone gave you the answer and ate your lunch. Because if the same problem was faced by you at a different time in your life, right? And when this person is not around to give you that freebie answer, you won't be able to come up with it, or you'll have a much harder time coming up with the answer because you didn't come up with the answer the first time. Does that make sense? So that is why giving answers is actually a bad idea. So it is much better to let people struggle and find the answer themselves, because that way they are equipped to find the answer when you're not around. Because I'll be stupid to believe that I'm immortal here. I'm going to be around all the time. You can email me like 500 years from now and get an answer from me. No, right? I got to set you up to make sure that you guys can go on and change the world without my help, right? So I'm sitting out here and enjoying my cup of coffee, and you guys are out there creating the next blockbuster app, right? So, and that is the goal of every single teacher. And I don't know where I was going with that, but certainly, that's one thing we can do. We will make sure that you are, coding, and you will be helped if you're absolutely stuck. And if there's, if over a lot of years of experience, our tutors and I know the places where students need help. Sometimes students may think, well, nobody's helping me here, and this is you don't get any help in this class. No, that's not true at all. Okay, you get all the help you need. The only thing you won't get is just answers. Okay, and some people may mistake that for saying, well, no answers means no help. No answers means that's good. It means you have to find the answers yourself. You won't just be, someone else won't come and eat your ice cream, as it were. Okay, so again, I think we're right on time to start coding. Someone who hasn't coded before, if you can take the screen and what do you want to code, by the way? Shall we code the histogram? Because that's one thing I wanted to do. Yeah, I have a version written in an ancient scripting language called Perl. Okay, so long before Python became popular, and all these other scripting languages, there's a language called Perl. PERL. It stands for Pattern Extraction and Reporting Language. PERL. That's why it's called Perl. And and I used to, when I needed to script, basically saying, well, I don't have the mood. I'm not in the mood to write a C++ program and compile it, especially since the program will change a lot of times. I don't want to recompile it each time. So I wrote it in Perl. Because Perl is a scripting interpreted language. If you want to make a change, make a change. It's right there, right? So I wrote it in Perl. And ever since then, I've been thinking, well, you know what, it would be really nice to just do an implementation in C++, because it'll be fun. Also for students to get an idea of how histogramming works. So if you are okay with that, that's the one that I would like to try, because I've been wanting to do that for a long time. Otherwise, but if you really have strong feelings about finding the second minimum or second maximum, I'm happy to do that too. Okay, so let me know. And anyone who wants to take the screen right now should just feel free to grab the screen. Okay, and hopefully someone who hasn't gone before. If you can grab the screen and open up Xcode or even online GDB, doesn't matter. Okay, online GDB or Xcode, and then we will start coding from there. Yes. Okay. Now I do see people on screen who haven't coded before, so there's a whole bunch of opportunity here. So feel free to do that. I'm going to try one more time to see if I can get into Zoom here. But it doesn't matter really, but we're just going to code here. Okay, so I'm just waiting for you guys to pick up the screen. So who wants to code today? And so let me know who wants to code today. Meanwhile, I will try to log out and log in. Who? All right, Jaden is back up. Okay, Jaden, you've coded before, Jaden. That's why you're back up. Okay.
Oh, do you want someone else to code that hasn't done it, or?
I'm sorry.
Do you want someone else to code that hasn't done it, or do you want me to go ahead?
Yes, exactly. Right. So you're back up, meaning if we don't get anybody else to code, you can code today. Yeah.
Okay.
All right. So someone who hasn't coded before, you just feel free to take the screen. Okay. You can see all the previous videos. Nobody got eaten up. Right. So we're a friendly bunch here. We're a friendly bunch here. And even when I take a break and disappear, I can hear all these other students helping the coder out. Okay. And chiming in with what needs to be typed. So please feel free to take the screen, open up and share the screen with your IDE or online GDB or one of those sites, and then we can start coding. Okay. So and what I'm thinking, what we'll do of doing today is essentially courses. I don't know, well, let me see. I don't know if it'll Zoom. I hope this worked. Okay. So I think what we'll do is we'll generate a vector, okay, an array of, I don't know, of a million numbers, okay? We'll generate a number, a vector of 1 million random numbers. And then we'll try and find, we'll try and see if there's a trend, okay? We'll try and see, and it is exactly the same, whether you use 1 million or 10 trillion numbers, okay? So if someone comes to you from, here is some sales data, right? And the sales data is stored in the Amazon cloud in our buckets. And there's about, 5 terabytes worth or 5 petabytes worth of data. And we want to find a trend. Exactly the same, right? Is you will find you'll do exactly the same thing, except it's going to take longer because there's more data. Unless you have more machines at your disposal, then you can use something like MapReduce, right? MapReduce or Hadoop, where you say, I'm going to, so much data. Obviously, I can't process all of that. So what I'm going to do is divide it into 10 chunks, okay? And give the data to 10 different machines. They can all do it simultaneously, right? And when they return the results, I'm just going to add up those numbers in the bins. That's faster, isn't it? Then if you told one person to add up everything, right? You chunked it up and say, add up your parts, and then I can add up your sums. Isn't that faster? That is basically the core idea behind what is called MapReduce or Hadoop. When Google publicized this technique called MapReduce back in 2005 or 2004, right? Is that this MapReduce is what we use to handle big computational problems. Well, actually, there are big computational problems. The computational problem is actually small. It's only the data that is big. That is the most important thing about these techniques like Hadoop and MapReduce. And because Hadoop in Java is just the MapReduce implementation in Java, essentially, right? And people always say, oh, in MapReduce, I got to do it in the cloud. And, I know MapReduce. No, MapReduce is just, a framework of taking a job, chopping it up, giving it to many people, and then they all come back and then joining up the results and giving it back. And that's much faster because you make use of more workers. Right? Each computer is a worker computer. So you can use more workers working simultaneously. So you can do the summation and get a result. So that's essentially what MapReduce is. And so since it is faster, the system MapReduce will basically say, here's this task. How do I figure out which person to give how much of the task to, right? And also that person has finished their job. They come back. Now I'm going to give them more. Right, so something that's not done, so you process it in chunks like that. You need a manager to take care of that, essentially, right? That is what the MapReduce framework is. So it's so simple. It's like 3 or 4, function calls that you basically need to understand. This is what they do, right? This will take it and chunk it up. That module will take the chunks and distribute it. That module is basically going to listen to these, people and say who's done. Okay, if you're done, take this new block. Okay, so that's all it does. But suppose you have 1,000 machines at your disposal, right? So the manager needs to be on the wall every single moment, right? It needs to know, all right, I've taken this big task and given it to 1,000 machines, and they're all going to come back, and I'm going to keep doing that until the whole thing is finished, right? So that's the MapReduce system. And where I was going with that was that, when in MapReduce, the most important thing to know is that the computational problem must be small. Right? But the data to process must be large. Now, so when the computational problem itself is really complicated, no matter how big the data is, MapReduce is not the right technique to use there, right? So that's one way you can find out if a person actually knows about MapReduce or not, right? The way of farming out big computational tasks is where they would use MapReduce. Is this a simple thing that just needs to happen over lots of data, or is it a complex thing that needs to happen over little data, right? If it's a complex thing that needs to happen over little data, nobody's going to cut the mustard for you, right? So MapReduce is not going to work because, first of all, you can't partition the data. You only have a little bit of data, and the task itself is inherently computationally bound. You can't make it faster by just throwing more CPU at it, right? There'll be all kinds of scheduling problems and issues, right? So on the other hand, if I want to do something in language modeling, for example, right? So you have terabytes and terabytes of data of all of the internet pages that are in the world, right? So you send a crawler out and sample every single page, web page on the world, in the world, everywhere, anywhere, you just sample all the words, and then you want to generate counts of all the words used, right? Let's just stick to English. Even that is huge, isn't it? You have petabytes of English data. Right, so it's just going to make counts of all the data, a number of times the word "and" is used, number of times the word Anthony appears in the data, and so on. You want to make these counts. You can't do that on a single computer. It's going to take a long time. However, you can do it if you farm it out, right, to 10,000 machines, 10,000 machines, you can do that with 10,000 machines, isn't it? Because all you're going to do is, every one of you take a small slice of the data and just come back to me and tell me how many times you see Anthony in that data, right? So now all of these machines will go, and in a fraction of the time they'll come back and say, well, I got Anthony 1 million times, 300 times, 5,000 times, and so on, right? Now you only have to add up these numbers and you get the whole sum. Yes. So that is a simple task, lots of data. That is where MapReduce is useful. So that way you can find out. So here's what we're going to do. We'll just generate a large data set, right? Large is 500, 100, well, 100 million. I don't know. We can do 100 million, right? If you do it in Xcode, we can do 100 million. I think, online GDB may time out, but it's exactly the same. So we'll generate a lot of numbers and then say, is there a trend? Is there a trend among these numbers? Okay, are certain numbers more likely to happen than other numbers, right? And we can look at the data, and I'll show you how you can look at the histogram and figure out a pattern. Okay, so I think it'll be really cool. Okay, and this will also be you can also look at this as a lecture 0 in machine learning, because machine learning, if you enroll in any course in machine learning, right, and enroll cold, meaning you haven't done any past courses in machine learning and you're doing one, if that instructor does not start you off with this kind of problem to do in the first hour, or maybe the first 10, 20, 30 minutes, right? Depending on your level of expertise. If they don't start you off with something like this, saying, here is a ton of data, try and find out what the mean of this data is. Is there a trend? Is everything equally likely, right? That should be the very first problem, because that kind of problem is not only at the CS2A level, meaning that you can do it, but also has scope to test if that person who's tackling this problem will make a good data engineer, right? Or have they got the ability to be trained in data engineering? Because that is essentially the core. You want to shoot a lot of data at them and find out how they look at it to discern any patterns in it, right? And so we can do that today. And once they say, all right, this kind of pattern I can find or I can't find, then you can suggest and say, well, okay, well, you can't find any pattern in the data if you look at it this way. However, right, if you take the same data and project it into some high dimensional space, well, I shouldn't say, but if you apply some mathematical function to it, right, and each data point is actually broken up into a sum of a list of coefficients of a series. Okay, now if you look at all the coefficients in the data points, we're basically taking each number and splitting it up into 5 numbers, right? If you have a way in which you can take each number and split it up into 5 numbers, okay, now your analysis can say, well, I actually found the data, a pattern in the data, because after I split each number up into 5, I can see that every single number has, the 5 components. The first component is small and the large component is big. Okay, or they balance each other out so that, when they sum it up, you can't see the pattern, but you break it up, you can see the pattern. Does that make sense? So we can try all of that today. And all of that is within the scope of CS2A. And so when they come up with this, and so that would be a machine learning technique, right? So when you say it's a simple, trivial, off-the-shelf data pattern identification algorithms, they didn't work. I can't see a pattern in the data, right? Then the machine learning teacher could say, well, okay, now let's take the big guns out. Okay, now we say you can't see anything here. Let's try and make this transformation to the data, right? So we're going to use this mathematical function, right, and apply that to all of the data points. Now we look at the output of the function and see if there's a pattern in there. Now, how people know? And there will be a pattern there. So how do people know? Right? Even though there's no pattern, if I look at it through this function lens, I can see a pattern. So how do they know this is the function to use? Because there's tons and tons of functions you can apply, right? How do they know this is the function I should use in order to tease out the pattern in the data? That is where machine learning is, right? And exactly the same, like I said before, in that function to use is your scientific theory, right? So you can look at lots and lots of data, you can't see any patterns, right? However, using the lens of saying, well, I'm going to use a function that will basically divide all the photons into 2 classes, right? This function will take the photons that are close to a star and put it on this side, photons that are not close to a star on that side. Now you can see the pattern. Previously, you couldn't see the pattern, right? Because that is basically a transformation you apply to the input data to take it into different space. right? Now, in this case, we only took 2 spaces, right? But there's no reason it should only be 2 spaces, right? Frequently, you'll look in machine learning and data science. I'm going to apply a function that basically takes that number and splits it up into an infinite number of numbers. Okay, not just 2 or 3, an infinite number of numbers. Because you know, if you take e to the x is 1 number, right? But you can decompose it using Taylor series. Quest number 4, right? I think you're going to do this in quest number 3 or 4, e-talks, right? So what do? You take the coefficient, sum of the coefficient. I think we did in class too, right? And how many coefficients are there? There's actually an infinite number of coefficients, isn't there? In the expansion, there's an infinite number of coefficients. So you take that number and split it up and into, apply that function, and now you have something to look at and say, well, maybe there's a pattern in here among the, but how do you know which function to use, right? So all of that only comes through that intuition, like saying, oh wait, I have an intuition that gravity is what makes that change to photon trajectories, right? How did they come up with that? Right, just by looking at lots and lots of data and saying, well, I think I got a gut feeling, right? I'm going to try this. I'm going to try this. That's how machine learning engineers work. Okay, just like real scientists, they'll look at the data and say, well, I can't see a pattern, but I'll look at it this way, so through this function. Okay, because I think the way that function behaves, it will be able to tease it out. And then you try many functions like that and say, well, there it is. Okay, and that's where that's also where the money is, right? Because there are so many functions, so many different ways, so many different perspectives of looking at something. The perspective that gives you the answer, which is not immediately obvious, that is worth a lot of money, right? You can say, well, I was able to find it. Nobody else was able to find it. And people say, oh, when I was young, people, the older people used to say, well, too bad everything has been invented now. You don't have anything to invent when you grow up, right? Because all the airplanes or radios and chariots or whatever it is, well, everything's already been invented. And some people used to say, but actually that's not true. It's the opposite. Now we have more things to discover than before because now we have more data, and within every sea of data there are so many patterns. And so scientific discovery and invention has now been broadened to include anywhere that you can see data. Anywhere you can see data, you can say, well, okay, there's the theory hidden there. I'll go and find the theory. Okay, and now even better is now the patterns hidden in theory, in the data, in scientific theories. Many times in scientific theories, you only get, a publication and fame and maybe a job or tenure out of it. But if you discover the same kind of pattern in data, it's not just a job or tenure anymore. You can actually get, for my discovery, I got like $5 million or $10 million because that thing was so hugely valuable to a company that they said, well, okay, well, come and join us. We'll give you this huge signing bonus. Okay, because that is exactly what we want. So that's why it is so valuable. Yeah. So if that makes sense, I would like to do that. But obviously, the person who takes the screen and starts sharing it will have the call on what we want to code today. Okay. So if they say, I want to code the histogram for data, we'll do that. Otherwise, we'll do, or if they say they want to do the, second minimum or second maximum, we'll do that. Okay. So anyway, that's enough of a spiel. Can someone please, I'm just talking on and on because nobody's picking up the screen. So if someone basically shares the screen, and if nobody does, I will ask Jaden. But Jaden has already had a chance. I want someone else to take a chance. And remember, okay, you don't have to be feel on the spot, because you just need to be in the capacity of a typist. If you won't actually, because when you start typing, you'll start typing ahead like Jose and everybody else eventually. But you start typing, and eventually you'll find that you're just typing ahead. All right. So you just have to function in the capacity of a typist initially if you have cold feet. Okay. Hey, Linchen, you are in front of a computer, right? You can take the code. Kate, okay, you're also, Kate, Kiki, Tim, Anthony are the only ones. Alexis actually should feel more compelled to take the screen, because I've never seen Alexis switch on her camera. Okay, so I don't even know if you're in class or not. Okay, because that's a static picture. So one way for you to establish your presence in class is to basically code one day, right? Take the screen, meaning that you don't have to share your camera, but you will be coding online live, okay? And that'll be a good opportunity for you also, right? I can guarantee that it's going to be a good learning opportunity. So especially if you've been missing classes, by coding, you can actually make up hugely for that, because you'll get familiar with what's being happening. And so please do take the screen. Alexis, are you here? Wow, oh yeah, okay. Oh yeah, Alexis, do you want to take the screen and code?
Okay.
Okay, or yes, no, okay, great. Okay, so you don't have to feel, hesitant about these things. Everybody here is a friend, and everybody's going to try and help you. And by the way, and Shangwen posted a very nice tip sheet for question number 4. Okay, I would like more of you to post tip sheets like that. Yeah, you can look at that as an example. Okay, not giving away all the answers, but just offering gentle tips, right, and pointers to saying, here's something that I was a gotcha for me. Maybe it's not going to be a gotcha for you, but just in case. All right, so just one. You don't have to say everything about a quest, but just even if it's 3 or 4 good tips in the forums, they all count. They'll be useful for you yourself later on when you come back and do your reflection. Also, it's going to be useful, obviously, for other classmates. Okay, so I hugely encourage posting these tip sheets, sharing your experiences, because Reddit shouldn't be dead like this. And when you post tip sheets, not under the foothill flare, you can actually say this is a tip sheet for the stilt, not stilt, right? J or serpent. You can pick the correct flare and say question number 5. This is a tip sheet. Okay, or even feedback. And things like that. So all of these things are appreciated by all of the students. Okay, so yeah, Alexis, go ahead, open up the screen, and by the way, Kate and Tim and Ling Chen, Jason too, right? And Kiki, right? You should all try and make up your mind to say there's only a few classes left. I think we're already into week 4. End of week 4. Next week is going to be week 5, and then things will happen really fast. Okay, so you have to make up your mind and say, I want to code at least once, as quickly as possible. Right? Take the first opportunity to code and say, I'll code today. Right? Especially if it's a brand new concept, it's easier to code because you don't have to come in with existing knowledge about it. You're going to be walked through, right? Talked through every single step that you're going to type. And someone's going to tell you, or I will tell you. And so you won't have any problems at all. And so make up your mind, take every opportunity to code, okay? And obviously we have backup people in class like, Jaden and Jose, they will all be able to code. But ideally someone who hasn't coded before. Alexis, Anthony, you too, right?
What are we going to code?
Yeah. Okay, so do you have a Mac or a PC?
I have a Mac.
Okay, good. So do you know how to use Xcode?
A little bit. Wait, are we gonna do the histogram?
Yeah, a histogram. Is that okay with you?
Yeah.
Okay, great. So let's do the histogram and open up Xcode. I'll walk you through the Xcode. Or if people, everybody votes against an Xcode interface and want to use online GDB, that's also fine. Okay, you can go to online GDB in a browser in a private tab. Okay, when you open a browser, make sure it's a private tab, and you can go to online GDB. You can code there. How about we just go to online GDB so that you can just share the code at the end of class and you can share the link and it'll be available for other students immediately, right? So why don't we do online GDB? Open up a browser, a private tab in a browser. Anthony, you also got to make sure, okay? You got to volunteer for coding one of these classes. It'll be pretty straightforward. Okay, everybody is going to be, everybody's got everybody's back here, okay, in class. And nobody will be left in the in the lurch and feeling, oh, I don't know what to do here. That will never happen to anyone. Okay, so in the worst case, I'm always there to say, make sure that you are comfortable. So Alexis, what you have to do is basically share your private browser window, either Chrome or Safari. Open it up and open a private tab in there, and then share that in Zoom. Share screen. And share that. So I hope this works.
Wait, can I do it next class?
Yeah, sure. How about someone else? But make sure you set up already before coming to class, and don't be absent. Okay, don't be absent because I got to code. I got to code if I go to class today and I'm going to be absent. No, that doesn't work. Okay, because I remember these things. So make it a point in your mind to say, okay, I'm going to prepare to code next class. Who else wants to code today? Anthony, Xiangwen, Ling Chang, Kate. Don't feel okay. Jason, Kiki. Just feel free and to volunteer to code. Okay, this is a great opportunity. This is a great opportunity. We're going to walk you through every single step. So all you have to do is just be a typist, and as you're typing, you know, the information will basically just plant itself for you to noodle on and you know, understand later. Yeah, it's I don't know how it works for you. Oh, who wants not here today? Because I'm trying this. It's a brand new iOS install. I think happened a few days ago. And why is it not? Maybe it's, you know, Safari. It's not authenticating me on SSO. Maybe one can let me know what he did. Who's going, by the way? We shouldn't be wasting so much time just figuring out who wants to code, okay? Because we want to be spending a lot of time coding, not trying to decide who is going to code, right? This is your opportunity to code. Kate, you want to code? Thank you so much. That's fantastic. Okay. Yeah. So yeah, I love it when people volunteer and say, "I'll do it." Okay, because that is the way. I mean, in order to find a job, you got to put yourself out there. Yes, and you can't be sitting in your home and not apply to companies and say someone is going to come and knock on my door and hire me. Oh, so like that. So this is all practice for that. Okay, thank you. And this is a browser window. Is it a browser window or an IDE? Hey, Kate, I can't hear you, by the way.
It's Xcode.
Oh, it is Xcode. Wow, I see. It looks so completely different. That's fine.
Move things around it.
Yeah, that's cool. Actually, I like it this way because you have more room on the screen. In fact, hit Command plus on Xcode. Oh, great. Okay, that's great. I think even better now. Now I can reduce the size of the screen, get more of you on screen. Okay, there you go. Excellent. All right, so let's put the customary comment on the top of the code saying, yeah, today's day. Oh, this is today's day class code. Today's class code. And on the next line, we'll say, we're going to generate a whole bunch of random numbers and try to find patterns in them. Okay, so that's all we're going to do. All right, so let's go to the first, let's go to main, and we'll do the thing. Yeah, this is what we usually do in classes, as you may remember. Yeah, get rid of the hello world also, leave the return in place. Okay, now what we're going to do, we'll put a comment inside of main, the first line of main, put a comment there saying, yeah, indent in the comment also, because inside of main. Yeah, okay. Now we'll say we're going to generate a ton of random numbers and try to find a pattern. And next line, yeah, break the line there. Go on the next line, yeah. Oh, it's funny, right? I'm pretty sure Jose or someone hit return and they got an automatic. That was Xcode too. I think it was Xcode. No, it was VS Code. So in VS Code, when you hit return on a comment, it automatically starts the next line with a comment. So it's not happening in Xcode. Maybe it's a config option. Okay, so find a pattern in it by histogramming the data. Okay, that's what we're going to do, right? So the first, and then a blank line there, and then say, first, let's create an array. First, let's create an array of a million, right? Let's say a million. Okay. Let's create an array of 1,000,000 numbers. Yeah. Okay. Now we're going to use what is called a native array. We're not going to use a vector like last class. We use a native array. The difference between a native array and a vector is that a native array is essentially just a block of memory set apart, right? In RAM on your computer, you have 8 gig or 32 gig or how much ever. It's all RAM chips, right? So when you say I want to store lots and lots of items of the exact same type, it has to be the exact same type. You cannot have an array that has different types in it, right? So for example, if I say I want an array in which I want to store 5,000 integers and 10,000 double of precision floating point numbers, you can't get an array like that, right? You can't have an array in which you have integers that are 2 bytes long, and then doubles that are 8 bytes long. It's not possible. And the reason it's not possible is because the whole reason arrays are important and useful to us is that all of them being the same size, every item in the array is the same size. I don't have, suppose I want to locate the 5,000th element in the array. I don't have to go to the first element and then walk 1, 2, 3, 4, 5, 6, all the way up to 5,000. That's time consuming, isn't it? Right? If I go I equals 1, I plus plus, until I find the 5,000 element, that's time consuming. However, if I know that every element is exactly the same size, I don't have to go to the first element and then walk. I can actually calculate exactly where the first element is, because I know the first element is stored this place in memory, okay? And each element is that big in size. So the 5,000th element must be that times 5,000 away from here. So I can go directly here. Does that make sense? So that is a power of an array, right? You know, that's the power of an array and vectors, and that's all we need to know, right? That is the only thing that distinguishes an array from other data types where you have to iteratively traverse, okay? In arrays, you don't have to iteratively traverse. You can go directly through calculation of where the address is. You can go right there, like along the hypotenuse of a right angle, right? Instead of like that. So does that make sense? Now, the reason we don't use native arrays mostly for 2 reasons, okay? One of them is that a native array is the way most people declare it is stored on what is called the stack of a computer. We haven't talked about functions and stacks, which we'll only do next week, right? And the stack is there's 2 places in which the program has memory to access. One of them is called a stack, right? The other one is a heap. Now the stack is a fixed amount of memory given to every computer. Every program that starts up there's a stack, and it's more like 100 megabytes or something like that. No matter how big your computer, the computer's RAM, is, the amount of stack memory a program gets is usually about 100 megabytes. So it's limited in size, so you can't have really big ass arrays on stack. So when you want a really, really big array, you say, well, I want an array, I should be on heap, because a heap is only limited by how many chips you have in your memory bank, okay? Suppose you have 5,000 terabytes of data on your computer, you can have an array that spans 5,000 terabytes, right? Because it's on the heap. And that power is available to you if you put the array on the heap. Well, technically speaking, you can also have a native array on the heap by using a new operator, which we'll cover later on. But once you go into creating arrays on the heap, what people usually do, professionals, is that they're not going to have a native array, right? They'll just say, give me a vector, right? A vector is automatically on the heap. Right? And then that vector, if you grow it to 5,000 terabytes, it'll just grow like that. The operating system will take care of that. So that's why, the vector is basically just your native array, and then taken and sugar-coated a little bit so that people don't have to be consciously aware every time that, well, you know what, I need to do this allocation, reallocation, take that array in memory and move it somewhere else because now it's grown bigger. All of those things automatically taken care of. That's all, right? That's the difference between a vector and a native array. But today, what we'll do is, because we're only going to generate 1 million random numbers, and 1 million random integers are 1 million random number integers times 4 is 4 million bytes, because each integer is 4 bytes. Yeah, each integer is 4 bytes. It's not 2, by the way. On this computer, Kate, most likely the laptop you're using today, I bet it's a 64-bit computer. Is it a 64-bit computer? It must be, right? And integers will be 4 bytes. And in fact, what we'll do is right at the beginning, I'll show you how to find the size. On line 14, hit enter. Hit enter, right? Put a comment. One more enter. Put a comment saying, before we get started, as an unrelated aside, okay? Before we, as an unrelated aside, let's find out how big integers are on this computer, okay? How big, next line, yeah, next line. Integers are on this computer, okay? And then you do a cout, left shift. Using names, thank you. So Kate, you can program already, it seems. You have some experience. Oh, you've been watching all the videos and you're staying on top of things. That is absolutely fantastic, okay? So that's great. Right, so cout, left shift, and then you're going to say, on this computer, integers, the size of an integer is, and int size is on this computer, and the size of an integer is. a colon, yeah, okay, and then left shift, and you're going to say size off, which by the way is a compiler directive. It's not a function. It's a compiler. You will find that you can Google and find out later on. Size off, one, yeah, and then open parentheses. Oh, you don't even need an open parentheses because it's a compiler directive, right? You can put a space there, a space, int, int, and then left shift and L after that, right? And L. Now, if you can compile it and run it right now. Oh, it actually requires a space, parentheses around. Oh, no underscore. Did you have a, oh, put the int in parentheses. Yeah, no, put the int in parentheses because, apparently it is a later version of C++. Right, now if you run it, we'll actually see how big integers are. And I think it's 4 on the most modern Macs, okay? Just run it. Now hit the triangle button at the top. I wonder why, even with Jose, it's taking this long to compile even simple programs on a Mac. In fact, even in my Mac is much older than yours. Even that is faster. I don't know what's going on. Why? Where's your console? Run again. Okay, click, run. Yeah, hit replace. Run. Using namespace. That's all correct. That's all correct.
It said when I was compiling the code, doing the example, it said it wasn't working with cout. It had to use std cout and std.
No, but she's got. See, on line 10, she's got using namespace standard, right? If you have that, you don't have to put std : cout. Where is the console? I can't see the console at all. All output is there on this computer. Cout on this computer. The size of an integer is and size of n and L. Oh, there you go. All right, how come it happened now? Did it take this long to compile and run your program? This is possible. Okay. And oh, you have a breakpoint. Okay, so click that blue tab in the margin. Click the blue tab in the margin. So double click it or drag it out on the left. Drag it out to your left. Drag it out to your left. You can? Yeah, all right, good. So that is a breakpoint, and use that in debugging. When you have a long program, right, and it's not working, what you can do is set a breakpoint like Kate accidentally did. Click in the margin, you get the blue tab, and then your program will basically run and stop right there. It won't take run the rest and wait for you to say, all right, can I go on to the next step, right? Yeah, you can execute it step by step and look at all the variables changing. And then you can find out, hey, that's why my program is not working, because the variable is supposed to change on line 47, it didn't change, okay? So that's a debugging tool. Breakpoints, so we won't do that. Now, now if you hit the triangle, it won't stop there. It'll just go all the way and complete it, right? Yeah, click that. It'll just, yeah, and it'll complete it and say, and it's 4 bytes, right? It actually says it's 4 bytes. Yeah, drag the middle bar over to the left. Yeah, there you go. Right, so it's 4. So my guess was correct. So 4 a million integers is basically just going to take 4 million bytes. Right, 4 million bytes in memory, because each integer is 4 bytes. Now, how much 4 million bytes is just 4 megabytes, isn't it? And 4 million bytes is 4 megabytes. Now, 4 million bytes for 4 megabytes is nothing. It's a piece of cake. Yeah, even simple old phones have more than 4 megabytes of memory, right? So and a stack even on a stack, not on the heap, right? So so I'm pretty sure that we'll be okay. So now you can comment out that line, all right? I'll comment out the line, and yeah, and then stick that line with the previous thing because it's unrelated to what we're going to do. Yeah, there you go. Thank you so much, right? So she's actually anticipating a lot of things that I'm saying. All right, now put a comment there saying we are going to generate, we're going to declare a vector. We're going to declare a vector of 1 million integers. Yeah, integers. So on the next line, you can say int space vec, right? We'll just say vec, VEC for vector, and square bracket open, close square brackets. Yeah, and then you can remove the space between the vec and the square brackets because they can touch them together. Okay, and inside the square brackets, we're going to say 1 million. But rather than say 1 million right there, let's not use a magic number. We'll say vec underscore size all caps, vec underscore size all caps. Now we have this constant. Let's go up to the top of main and then we can define that constant right there, enter, and say const size t, const space size t underscore t, size underscore t, vec underscore size equals 1000 times 1000. Okay, so that's a habit of mine. Anytime I have a number with lots and lots of zeros, I just break it up into products of 1000, because the compiler will do the calculation. It's not the runtime system, and it'll put the right number in there. But for humans, it's a whole lot easier to see that it's 1 million rather than if you just have lots and lots of zeros. Okay, now I put a blank line after that, so that declarations are separated. Okay, now there you go. After line 23, hit enter. One more blank line, and say now we're going to fill that vector. We're going to fill that vector with 1 million random integers. Okay, fill that vector with 1 million with integers, because it's 1 million, right? So with 1 million integers. Okay, right now on the next line, do you want me to do that, or you can do that yourself? We're just to create a for loop, right? And hopefully Kate is not going to type this, because I can see that she probably knows what needs to be typed. It'll be nice if someone else tells Kate what needs to be typed for this part. I'll say put a comment there. Yeah, one more comment line there. Kate, can you put a comment there? Yeah, right there, and say we're gonna write a for loop, right? To do, and because you're gonna do this, okay, to do. And make it one word, because then the compiler will pick it up and put a tab for you and all, right? Yeah, right. Yeah, there you go. It's bold, which means it actually recognizes it's a to-do item. Okay, so we are going to for loop to stuff our random integers into our vector, Okay, now can I leave that in your hands, because it's like 2 lines. It's 2 lines of code, and should be easy for you to do. Not Kate, okay? Someone else basically has to call out the code, and she'll type it in. And we don't have to do it now, and we can do it later. One thing that we can do before I leave that part in your hands is write a for loop. Yeah, let's do the srand call, okay, right at the top, so that we don't get the same sequence of random numbers every time. So after on line 13, hit enter one more time. Now we say srand, and I'm not going to go into the details of why we use srand there. It's there in the previous classes video, right? Previous lecture. You can take a look there. Srand open bracket, and one more open bracket, and say, well, no, not square bracket. Open, open. No. The parentheses, open parentheses. I said bracket. Okay, open parent. Okay, and in there, one more open parent, and say no open parent. One more of those. One more open parentheses. Yeah. Now you say unsigned in there. Unsigned inside there. You say unsigned, and then outside of that, there you go. Space. Time, time. Yeah. Time. Because we want to read the clock, right? So there's a system clock, because time value. Open parentheses. No. Just get rid of the word value. Word value. Okay, open parentheses, and you want to put 0 capital L in there. 0 capital L. Okay, and put a semicolon at the very end of the line. And then you can just put the comment on the same line saying seed the random number generator, because we say this comment every single time, but it helps for students to know, right? Seed the random generator. Okay, good. All right, now this to do now, it should be easy enough for one of you to call out and Kate to type, so we won't go into the details. Now put more blank lines in there. And then we have a comment after that. First, let's create an array of 1 million numbers. We can cut the comment, and put it above line 24, right? Because it's still relevant. Cut the comment, yeah, above line 24. Yeah, stick it to the next comment block, actually. Yeah, there. That's much better. Okay, all right. So now, there we can put a to do there also. Yeah, comment and to do. We're going to call our function to histogram the data and return a vector of binned counts. Okay, binned, binned counts. Counts, not accounts, right? Bin counts. Now here's what we're going to do. On the next line, we'll also use a vector. Okay, we're going to use a native array, but we'll also use a vector, and you'll see that the way we use them is exactly the same. However, we will be using some property of a vector, which is harder to get out of a native array, right? So here's what we're going to do. Right immediately after line 32, right? Immediately after line 32, right? Say vector of int, right? Vector of vector angle bracket, angle bracket, angle bracket. There's so many different brackets. Okay, curly brace and then square bracket and angle bracket. Okay, angle is less than, angle less than sign, right? You say unsigned int, right? Or you can even say size t, but unsigned int is good, right? Unsigned int, yeah. Space counts. Okay, so that's going to be our vector. And then let's say we want 10 bins. No, let's say we want to have 25 bins. Okay, so after counts, open parentheses. I say we want to have 25 bins, meaning that no matter how many numbers we want to histogram, we're going to put them in 25 equally sized bins, right? So if you have 1,000,000 numbers that I want to histogram, each bin will be, what's 1,000,000 divided by 25, right? So 1,000,000 divided by 100 is 10,000, divided by 4 is going to be 2,500. Okay, so this is 25. No, million. No, yeah, divide by 100. What was I saying? Oh, times 4. So it's going to be 400. Whatever. Right? So we want to have 20. So we want to have these bins, and then we're going to take. We'll find out eventually, right? When we do this. Okay. Now put a semicolon after the closing parentheses. Right. On the next line, now one more blank line, right? And then we're going to call our. We're going to call our function right there. Okay. So you can say. Yeah, so you can say histogram data. This is going to be our function call. Okay, underscore data, open parentheses. We're going to pass our vec, comma, counts. Okay, now there's a huge subtlety here, and you have to think about this for at least 10 minutes after class. Whenever, talk about it with each other. We're going to create a function that takes 2 parameters. Okay, and this will become a whole lot more clear next week when we talk about functions. Okay, so you need to ponder what we're doing now, and whatever you don't understand, it has to be live in your head, meaning floating at the top of your mental ocean. It shouldn't be sunk below, because next week when we talk about functions and the way that parameters are passed, this will make a whole lot more sense. But if you forget this, and next week it'll be slightly harder. Okay, so what is and above that function, let's put a comment, right? And that comment is going to say a subtle thing about this function, which will become clear next week. A subtle thing about this function, yeah, which will become clear next week. Colon. On the next line, you say, right? A vec is passed. Vec and counts are both vectors that are passed by reference and not copy. Okay, reference and not copy, and you can say not in uppercase, right? Because emphasize that not should be right. Not what that means, and that is something you can look up and find out, and we'll talk about that in detail next week. Okay, when you take a function and pass it a parameter by reference and not copy, that means I'm going to give you this big data set. However, I don't want to take a copy of it and give it to you. I'm giving you the actual data set, meaning I'm going to save myself the time of copying it. I'm going to give you the whole thing because it's big. So just be mindful that you've got the actual thing. If you change it, my actual vector will get changed, right? So that is called passing by reference and not by copy. C++, in contrast with other languages, gives you this very, very easy way of choosing when you want to pass an object by copy or reference. In other languages, it's very hard. Okay, take Java, for instance. In Java, everything is passed as a pointer. I don't know how many of you are familiar with Java. Everything is passed as a pointer. Now, if you want to pass something by copy and not a reference, right? So saying, I'm going to pass you something and it's the original. I'm passing you the original, not a copy of the original. So super duper careful. It's the original Mona Lisa. You can't go in and change things in it, right? So you pass the original. You got to be super duper careful, right? Not a copy of it. And in other languages, if you want to do that, it's very hard. And in Java, if you want to emulate the effect of passing by copy, you got to do a whole lot of crazy things. Okay, you got to intercept that and make a a copy. You have to make a copy yourself and pass it to the function. It's a real pain. In C++, everything is like that, right? Because you say, just by saying this is a function and it takes parameters by copy, that's the default. All right, if you don't want to take it by copy, you want to take the original, you can make that happen like in a snap of a function just by changing the signature, as you'll see what we're doing, right? So we're going to play around with a lot more with copy and reference next week, but today you actually get a taste of it. Okay, so all right, so that and then on the next line, one more blank line, and you can say comment again, and we say now we will histogram the counts. Now we'll histogram the counts by printing stars, right? By printing stars for by printing stars for each for the count in each bin, count in each bin. In other words, what we're going to do is we get these counts, right? You say here is a bunch of numbers, and here is a vector of bins. Now count these numbers and say, each time I see a number that is in the range of 0 to 40,000, I'm gonna put it in this bin. If it's 41,000 to 80,000 number, here. So at the end, you can count the numbers, right? So you can tell in this bin, so many numbers fell in that bin, so many numbers fell in this bin, right? So you have these counts. And now how many bins you have? You only have 25 bins. Now, because you only have 25 bins, I can actually print the bins, right? And say bin number 1 has a count of 300. Bin number 2 has a count of 200, and so in order you can actually put the actual numbers, or you can print stars, right? 300 is represented by 30 stars, 200 20 stars, right? 15, right? 1.5 stars, things like that. So right, so you can print stars to indicate the size of each number. And the reason we can do that is I found is that when you do that, when you look at just the stars printed out, you can see a pattern. And you will see that pattern, okay? So what we're going to do here is I will put a to-do there, right? So make that a to-do, and then what do you want to do, right? So yeah, we can. Let's not make it a to-do. I'll walk you through this code, okay? Because I don't want you to waste time on that. If you when you get to this, on the next line we say for size t I equals for size t I equals 0. For size t I equals 0. Size underscore t, yeah. Size underscore t is actually a data type, just like integer, float, double, and so on, right? And then I less than counts dot size, open close, and then I plus plus, right? And on the next line, and a curly brace actually, because we're going to have a body there. We'll have multiple lines. I think we'll have multiple lines. Right, right. So, in fact, what we'll do is above line 40. Let's put one more comment there. One more comment, right? One more comment above the for loop. Yeah. The size of each bin, right? So the size of each bin is essentially. Hang on. I don't want to say size of each bin. I will say the likely count in each bin, is going to be 1,000,000 numbers, right? In n bins, basically have 1,000,000 divided by n in each. Yes. So counts.size is the number. How many? We have 25 bins. In our case, we have 25 bins. In fact, what we'll do is go to line 32 and hit enter. Go to line 32 and hit enter. Enter there, okay, and put a const size t space size underscore t space num underscore bins, all caps, num underscore bins, right? Anytime we have a const, use all caps for the variable, so that when people are reading your code, when they see that, they know it's a const, right? So it's easier. Equals 25, and then change that 25 on the next line to num bins. Okay, now it's going to be not one. You can change the on line 41. Change is going to be 1,000,000 numbers. Change 1,000,000 numbers on line 41 to vec underscore size And then you can change it divided by to the forward slash, which is a dividing sign, division sign. Yeah, divided by number of bins. Okay, so does that make sense to everybody? So that's a number, average number. If everything was uniform, that's the average number you can find in each bin. So now we know that each bin would have approximately that many numbers in there, right? That many numbers in there. And if it was uniform, that's what it would be. Now let's assume that it's not uniform, and it's actually some bins could have more, some bins could have less, which means that maybe some bins could have twice that number. So let's assume that the number of stars we need to print is going to be, we want to fit them all in one line. So we'll say that vector size number of bins and divided by, oh, we'll have to find out. Well, all right, we'll run it and then we'll find out. Okay, so all right, in here we're going to say okay, here for I equals 0, I less than counts dot size. All right, we can actually do a cout right there. Cout, and then bin 1 within quotes, bin 1. Yeah, or you can say bin 0. You can just starting from 0, right? Bin 0. Bin. In fact, it's a bin, and then bin. Yeah, get rid of 0. Get rid of 0. Bin, and then outside of the double quotes, say left shift again. I, and then left shift, and within quotes you say colon space. Yeah, and then colon space, and then you're going to say count square bracket I, count square bracket I, right? And then endl after that. All right. So now on the next line, you say the above only, not printing stars yet. We only have the total counts, right? We're not printing stars yet to show how big each number is. So put a comment there saying the above is only prints the numbers, the counts, but not the counts represented as a line of stars. Okay, so that's basically not counts represented by a line of stars yet. Okay, all right. So now that is sufficient for us to actually make sure the rest of it works, and then we'll come back and print the stars. Okay, so leave this now. We can go and implement the function. So the function histogram data is what we're going to implement. Go right on top of main, right? So and then let's make this a void function, right? It's not going to return anything, right? So void, and then open parentheses. It's taking two parameters. They're both passed by reference. However, we want to make sure that the original data, which we are passing to this function by reference, it's because it's original, right? We can't send the original and say, well, it's the original, I trust you not to mess with it. So we can be better than that and say, not only do I not trust you, I'm going to make sure that I send you the original, but you don't have the ability to change the original, right? So we can actually enforce that in C++. And the way you do that is say const, and then what was it? Array, right? So const array. Const. What was it? Int. Open square bracket, close square bracket, right there. Right. That says it is an array of integers, but it's a constant one. You can't go in and try and change it. Okay. Space. No. We have to give it a name, right? Space vec, right? So you can call it vec here also, comma, and then the other also. Oh, and by the way, one thing we forgot is after int put just before the word vec, put the ampersand sign, right? The shift 7 ampersand. All right, so that says it's being passed as a reference. That ampersand says that's the thing that we have to get used to as C++ programmers. The ampersand in that context means that variable is being passed by reference, the original, not a copy. If you see the ampersand in front of variable, it's not a copy, it's the original. Okay, and then to make double sure that we don't fool around with the original and change it, we say it's const. And that way the compiler has our back, and the compiler will prevent us from changing back. So the next parameter after the comma is going to be our counts, right? So you can say int. No, it's actually vector, because our thing is a vector, right? So vector, angle bracket, unsigned int, Yeah, close the angle bracket. Yeah, get rid of the space. Yeah, all right. Now space ampersand again. And now you're going to say counts. Okay, now, yeah, that's it, right? Now, yeah, clean it up there, and then put a curly brace at the end, and we'll go into the body of the function and fill it out. Right? Okay, all right. So now this signature, let's put a comment on top of line 12, right? As to, because the signature is very unique, right? Yeah, comment and say note, right? Note, all uppercase, note. And so the first parameter is passed as a constant vector. Now we got to get into this. Why does it say, is this an error? It's probably because of the signature. We'll find out. Okay. And the second parameter is passed as a non-constant vector. Next line. Yeah, next line. But both are passed by reference, right? And then in parentheses, you can say original is not copied. Okay, so does it make sense? Everybody, is everybody okay with this so far? Okay, now that, so all we have, oh, by the way, why does it say, let's just use Google really quickly to find out, rather than me trying to mess around trying to remember how this is done. Is go to Google in a tab of your, if you can share it, that's even better, because everybody will be able to, you know, follow us. So if you can just go to a Google tab, private Google tab in any browser. I want to find out how in C++, how to declare an array passed by reference. How to declare an array passed by reference. C++, yeah. How to declare array passed by reference. Enter. Arrays can be passed by reference or array. Yeah, click that. Click the Stack Overflow link. All right. Oh, I see. Okay. All right. Okay. So let's go back. I know. So if we go back to our code. Oh, hang on. Oh, no. I'm looking at the wrong thing. That guy asked a question. We want to look at some guy who gave an answer. All right. For pass by reference. Oh, I'm so sorry. Yeah. I've forgotten. After years of programming, even I've forgotten this. Just go back to a code. Code and const. Yeah. Let me just go back to the code. All right. So so get rid of the square brackets after int, right? Get rid of the square brackets after int. Yeah. All right. Oh, why does it? Oh, geez. Yeah, you got this. And put the square brackets after vec, right? It was just in the wrong place. I think that should work. Okay. So, all right, good. So we're passing. What does it say? My mouse over that. I want to see the whole thing. What? Vec declared as array. How can you go back to the Stack Overflow page? I'm so sorry. If that doesn't, if we can't find it, we'll just use a vector for both. It doesn't really matter. In fact, why don't we use a vector for both instead of wasting time on this? Because we can finding out, just Googling how to pass vectors and arrays, it'll be 5 minutes. Okay. If you're stuck, I can find out and let you know later on. But just let's use vectors all around. So go back to your main, and we'll turn the other one also into a vector. Okay. So turn that one also, instead of int vec size, use a vector of int. Right, online. Online. There you go. Yeah. So turn that into vector, and then angle bracket unsigned. Yeah, angle bracket. Yeah. And then you say vec right there. And instead of square brackets vec size, you're going to turn the square brackets into parentheses. Yeah, and if we have time at the end of class, I can look up on Google with you the format of passing this thing. Okay, implicit sanction of that template vector. Oh, we didn't include a hash include vector at the top? Oh yes, we forgot, right? So after IO stream, yeah, hash include vector, and put a black line after that too, so that we separate the includes from. Yeah, enter. Now that error should be gone. You save it, vector unsigned in. Good. Everything on, and no errors up there too, right? In the, oh, I saw something else. Back. Yeah, of course. Now we can change the signature here also, right? On no, in our function, change the signature so that, yeah, you say const vector. You can leave the const and change the int into vector, angle bracket string, int angle bracket unsigned int, and close, and then get rid of the square brackets at the end. Okay, right. So that should take care of it. So we're passing both vectors, but one of them is a const and the other one is a non-const. Okay, now in here, all we're going to do is first, within comments, we say find the size of each bin, right? Find the size of each bin, right? Within comments, you say find the size of each bin. Right, and as on the next line, we're going to say size t bin size equals size t size underscore t bin underscore size equals and then what is the size of each bin? It is basically the size of the vector divided by the size of by the number of bins, isn't it? The size of the vector divided by the number of bins. That's the size of each bin. So you can basically say size of vec. Oh, actually, vec dot size. There's too many things happening here, right? Vec dot size, open close, and then divided by counts dot size. Is everybody okay so far? Okay, that's the number of bins. All right. Now, all we're going to do here is essentially on the next line, put blanks, one more blank line, right? Comment there. Now we just bin all of the numbers in vec into their respective counts, into the corresponding counts. All the bin all the numbers in the vector, bin all the numbers in vec into their corresponding bins. Okay, so all we have to do here is for size t I equals 0, I less than vec dot size, yeah, and then I plus plus, yeah, and then yeah. Now we're going to have right. So we're going to find put a comment there saying find the bin for the ith number. Find the bin for the ith number. Find the bin for the ith number. Okay. And so how do you find the bin for the ith number? On the next line, you basically say, let's take the number and we want to find out which bin it falls into. So we take that number divided by the number of bins. Yes, we divide it by the number of bins, and the quotient tells us which bin it falls into. Yes or no? This is a right. So if I take a number and divide it by the number of bins, and I get 0. Oh, actually, no. If I divide it by the number of bins, and I need to know which bin it falls into. So 0 to, let's say if it says 100 numbers, 0 to 10. If I divide it by 10, I get so all right. There's actually, it should be possible to do it in a one-line arithmetic statement, and I'm totally blanking on that right now. We'll use an if statement, and by the time we complete the if statement, I'm pretty sure it'll come to me. Okay, so all right. So if vec of I within square bracket within parentheses. Okay, if vec of I if open parentheses. Yeah, if vec of I. No, square bracket I, I'm sorry, but vec square bracket I is greater than 0 and vec of I is less than bin size times I, right? Bin size times I. Right, does it work? I think so. If each bin is 10 and then 0 times 10. Okay. Oh, so bin size times I, times I plus 1. It should be times I plus 1 within parentheses. Is that okay? Yeah. So I want to make sure that everybody's following along here. All I'm trying to do is take the first number, and I want to find out which of the bins it has to be in. The first bin starts at 0 and ends at bin size times 1. Yes, if each bin is has 100,000 elements in it, the first bin goes from 0 to 100,000. Well, 99,999, but we'll call it 100,000. Yes, the first bin goes from 0 to 100,000. The second bin goes from 100,000 to 200,000. Yes or no so far? So to find the bin in which that number goes, all I need to do is take that number, divide it by the number of bins. It's not divided by the number of bins, right? So actually, that's what it is, right? So I need to divide it by the number of bins, and then we'll go. The thought is coming to me, but it's slipping at the last moment. Okay, so we're going to leave that alone. But we'll just do it this way. So now we know it goes in bin number 1, right? So we if it's less than that, we say counts of I, count square bracket I, and then plus plus. All right, that's it, right? And enter. On the next line, you're going to say if vec of I. And in fact, you can say else if, right? You can say else if, else space if, because you don't want to be testing everyone. If one of them matches, you don't have to do the rest, right? So in front of the if, if you can say else if. Okay, all right. So if vec of I is greater than or equal to bin size times I plus 1. Yeah. In fact, this here's where you'll find it's easier to put spaces around the operators, right? Like greater than or equal to, and all these things. Yeah. There you go. Thank you. There also. Okay. And double ampersand. Oh, and by the way, the first ampersand is double ampersand, not single one. Okay. Yeah. Right here also. And vec of I is less than bin size times I plus 2. No, bin size times I plus 2, right? Now, now then you go, in every case it is counts. No, actually it's, oh, I see. Okay, so now where you say counts of I plus plus on line 25, that's counts of 0 plus plus, right? Counts of 0 plus plus, because it goes in the first bin if it's in the first interval, right? Now it's in the second interval, you say counts of 1 plus plus. Counts of 1 plus plus. Now copy that whole thing and put it there one more line, and then we can see the pattern emerge, and then we should be able to substitute all the if statements by one line, I think, right? So copy line 26 and 27. Triple click on line 26 and 27. Yeah, and then copy it one more time under that. Right? Now you can say vec of I is then I plus 2 now, I plus 2 and I plus 3. It goes in the second bin, right? Now I'm going to think of a pattern that I can use instead of using many if statements. Is there a way in which I can do it using a single line, right? So I'm going to think for a couple of minutes or a minute, and you guys can also think while I'm thinking to see if and then on the next line, you say, open a comment there, and they say ... etc. We need to do this for all of the bins, right? We need to do this for all of the bins. Now, do this for all the bins. Yes. So can you do this in a loop? Because you're going to go through the loops and look at the structure of what we've got in there, right? So what we need to do is essentially, can we do it in a loop, or can we do it even without a loop, right? So on the next line, we'll try and do it without, right? So on the next line, oh, you're doing all that? All right, so get rid of that comment on that line. In fact, no, get rid of that line. Get rid of that line. We'll actually try and do that right now. Okay. So what we want to do is if vec of I, yeah. All right. So we have to do a for loop there. right? So for loop, we need to do a for loop because you say vec of I divided by the vec of I, it falls in a particular interval. Do we still need to have a for loop to go through? I'm thinking, and you guys should also be thinking, right? You shouldn't be waiting for me to think and say, well, this is what it is. So what I'm trying to do is, can I make this simpler, right? We know how to do this with multiple statements like that. Can I make it simpler without using a for loop so that I can actually calculate which bin it should go to? Each number, I get a number, I want to calculate which bin it goes to and just increment that count, that bar like that, okay? So how can I calculate which bin that number goes into? So I can calculate that by saying how many, when I divide, yeah, okay, all right. So what I can do is instead of the for loop, and I got the answer, right? Do you want me to tell you what the answer is, or do you want, does someone want to take a stab at it? It doesn't matter if it's wrong, okay? Totally does not matter if it's wrong. What I want to know is I have a number. I want to find out which bin it goes into because I want to increment that bin. That's all I want to do, right? So look at the previous two things that I've done. I've got a number, I found which bin it's going into, and I'm incrementing the bin, isn't it? But however, I'm doing it in a stupid ass way because I'm taking that number and comparing it in different ranges and then incrementing that. But I'm saying, is there an easier way to do that so that I don't have to go compare it so many times? I just find out which bin and increment that. Is there a way to do that? Can someone come think of a way? Even if it's wrong, that's fine. Some basic arithmetic operations. We want to find out which bin it goes into. Can someone take a crack at it? Otherwise, I'll tell you, right? How 30 seconds, and I'll tell you how to do it, right? So if you want to take a crack at it, that's fine, right? So I'm pretty sure Kate has some ideas because she's smiling, right? But if you know, that's it's okay to just any idea, try it out if you want to. Otherwise, you'll lose the opportunity. I'll tell you what the answer is, or at least I'll tell you what I think the answer is, and we'll try it out. And if it works, it works. All right. But there's an opportunity for you to take a crack at it. You want to try, or do you want me to tell you? In fact, even me, I'm just thinking I know, right? We have to try it out. You want to try? Does anybody want to try? I want to find out the bin number. Which bin does each number go into? Remember, we have the bin size. We've calculated the bin size. Yes? So we know how many numbers are in each bin. So all I have to do in order to find the bin number is simply divide the number that I've got by the bin. Hang on. Oh, geez. You know what? That assumes that I have. Okay, we need to make not now. All right. So we need to know what the maximum number is somewhere. Can we go back to main one more time, please? I want to make one more change in main. Okay. So at the top filling, right? No, go to the place where you have the const declaration in main, right? All right. So under there, on the next line, you say const int max number. Okay, const int max underscore number, uppercase. Yeah, number equals, let's say 10 million. Okay, 10 million numbers. So 10 times 1,000 times 1,000. So in other words, what we're going to do is when we generate these numbers, where 10 million, a rand will not generate 10 million numbers. Let's say 4 million. Const, yeah, 4 million, and change the int to unsigned. Okay, or change into unsigned. And then where we have a vector, where do we declare the vector? Declare the vector itself. Unsigned. Okay, good. So and when we fill where do we fill them with random numbers? Oh, that you have to do that. I left that with you. Where do we fill it? All right, we'll do it. Okay, I'll just tell you. Yeah, so get rid of the to do. I'll just tell you what goes there. But you'll know what I'm. You'll know what that's what needs to go there, right? So for size t I equals, so put in a for loop there, and it loops over all of the elements in the vector, right? So I equals 0, I less than vector dot size, I plus plus. Semicolon I plus plus. On the next line, you can just say, no, you don't even need that. You don't need that because it's just going to be one line. So you can get rid of that. Yeah, on the next line, just say vec square bracket I equals. Now we call our a space around the equals. Yeah. So we can call rand our friend. Okay, rand open close space percent max. You got that thing there, max int, max number or something like that. What do you call it? Max number. Okay, there you go. All right. So what that and semicolon. And then in the comment on line 52, 1 million integers less than max number, right? You can say less than max number. Yeah. Now, why is this needed? Because only if we know the maximum possible number, we can determine the number of bins. Now, because we know the max number, we're going to pass the max number in to our function also. So where do you call that function? Where do you call the function? Histogram. Right? Yeah, there. The third parameter is going to be max number. Okay, max number. Now, now go back to our function. Right? And here, the bin size is not divided by the number of elements in the vector. The bin size is basically is going to be change vector.size into max number. Oh yeah, there you go. Where you had your cursor, that's good, right? And you say, I think it's unsigned max, right? Unsigned space max. All right, I think, or you can say max underscore number if you want, max underscore number. That's clearer. Max number. I wonder if it can make it smaller. Get rid of the word int after unsigned. You'll give it more space, right? Yeah, get rid of that because unsigned is the same as unsigned int. They're the same in C++. So we can save space. Well, it still goes to 2 lines. Well, I won't go in 2 lines in a different font, maybe. That's fine, right? So, so bin size should be, instead of vec size divided by, it should be max number divided by, right? Bin size on line 19. Yeah, it should be max number. And it's not a function call, right? It's just a value. It's a max number. Yeah, sorry. Jaden, you have a question? I wasn't looking at you.
Yeah, there's a, okay, I don't know, did we define vec.size or vec? Because I've been getting some errors like with vec.size, like around line 20, or I'm not sure where it is, saying that it's an use of undeclared identifier.
Is this in your function or is it in main?
I think it's within the void.
Oh, it's in the function. Okay. Do you have vec declared as a function parameter on line 17? Do you have that? It should look exactly the same as what Kate's got on screen there. Right? Line 17 should be the same. Do you have that? The first parameter is your vector.
Yeah, there we go. I accidentally put a T with vec.
I see. Oh, yeah, it wasn't there before?
Okay, cool. Yeah, it was vec
you're good now?
instead of vec.
Now? Awesome. All right. So now, now we can go to, we don't need the for loop, right? So where we on line 31? On line 31, you can say size t, bin number equals size t, bin number equals bin underscore number. We can just say bin num if you want. Okay, that's easier. Equals what is it? Bin size. No. So vec square bracket I. You want to take that number vec square bracket I is divided by bin size. Now that gives us the bin inside of which that number should increment the count. Now, are we all okay with that? That is, it takes a little bit of thinking, the math part of it. What we're trying to do is, given a number, we want to know which bin should that number increment. If that number is under 40,000, it should increment the first bin. If it's between 40,000 and 80,000, it should increment the second bin and so on. Yes? Each number in the vector needs to tell our counts place, the counts vector, hey, counts vector, I fall in the first bin. Hey, counts vector, I fall in the second bin. Hey, counts vector, I fall in the 15th bin, and so on. Yes or no? Each number it needs to tell. Now, how does it know which bin it falls into? All it needs to do is take the size of each bin and divide itself by the size of each bin, and that will tell it which bin it falls into, right? If it was 70,000, 70,000 divided by 40,000 is 1, isn't it? Because integer division, everything is integer division. 70,000, so that means I'm falling in the first bin. So if I divide the number by the bin size, I get the bin number. This is a subtle point. Everybody needs to be absolutely clear on this. Yes? Okay, so on the next line, all you need to do is counts, square bracket, counts, square bracket, bin number, and then plus plus at the end, and semicolon. Right? Now you can get rid of all of that. You can. All right. I see. We need to put a comment. We need to put a comment to say what it is, right? So put a comment there saying, first find which bin this number should increment, and then increment that bin, right? All right, okay, and that is it, by the way. All right, that is it. We should be able to run the program now, and we will actually see the counts. I think if there are no bugs, right? Obviously, there are no syntactical bugs because there's no red ink, right? If this is, if there's red ink, there's syntax errors. No syntax errors. So if you compile it, and it will run, but there may be logic errors, right? Maybe there's an error in the way that I thought about the problem and solving it. That we'll find out now. That's the exciting part. Okay, now increase the size. Increase the size. Right, there you go. We generated that many numbers, and we have stop anywhere, right? We have stop anywhere. Yeah, there you go. Bin 8, for example. Take bin 8. In all of the numbers in the vector, there were 40,125 numbers that fell in bin 8. And if you go to the very first bin, bin 0, there's 40,095 numbers that were in that range. 0 to, right? Now, in fact, we can do something cool and also print the ranges there. So if you go back to your main where you print it out, right? Yeah, there also before the for loop starts, yeah, there you say size t bin size equals, and you want exactly the same thing. You don't want to calculate the size of each bin, right? Size t is a maximum number divided by counts.size, right? Size t, bin size equals. In fact, you can even copy that line and put it there, but it's yeah, and say equals a max number. Yeah, a max. Yeah, that was correct. Max underscore number. Oh, I see. You hit enter to autocomplete, and it didn't autocomplete. Yes, I think that's what happened. Yeah, right. Never mind. So divided by. I think what was it? Counts.size, right? Counts.size. All right, that's it. All right. Let's make a small cosmetic change, and in fact, it'll also introduce to you a very nice feature of Xcode, right? So now click on the word counts. Click on the word counts, and right click now. Right click on the word, and right click on the word. Right click on the word. Right. You have something called refactor. Click refactor. Right. Rename it. Now, here's what we're going to do, right? Look at that. When you click that, Xcode automatically picks up everywhere in your program that variable is used, okay? Now, if that is a variable that is used in many files, Xcode will take care of that too, right? This is really cool. Now you change counts to bins, right? Because let's not say bin in counts, so let's call it bins, right? Everything changes, right? So you only change one place and it changed all the variables. Isn't that cool? Right, that's cool. The only place it wouldn't have changed it is in your function, right? So go to your function, because it's a different function, it's a different scope, right? So go to your function right at the top. That'll still say counts, right? And you can double click that and also refactor that, right? Change that into bins. Also save you some space now, right? Okay, there you go. Now, now you can go back to your main. Let's tidy it up in main. All right, so now inside of the for loop, let's see the first line inside the for loop, the first line before the cout, right? Right. So what we want to do is size t space lower end of bin. So bin, how do we call it? Lower end of bin, the left side of bin, or bin min and bin max. Okay, well, let's call it bin min and bin max. Bin min and bin max. Okay, bin min is the smallest number in that range. Bin max is the largest number in that range. Okay, bin min equals I star bin size. I space bin size, right? Bin size. Yes, semicolon, and then bin max equals size. And again, honestly, you can do that on the same line, right? After I star bin size, put a comma, space, yeah, and then bin max equals. I'm pretty sure you already know some other programming language, Kate. You're doing all the right things, even as I'm speaking. So that's kind of cool, right? Bin max equals I plus 1 star bin size. Okay, now that we have this, enter and put an enter there, right? Now in our on line 66 where we print it out, we can actually print it out much more nicely, saying these are this bin spans numbers from this to this. Okay, so what we want to do is bin I, and then before the colon, right? No, yeah, left shift one more time. Left shift one more time. Yeah, there. Okay, there. Yeah, put a double quote, and inside the double quote put square bracket, right? And now I'll go outside the square bracket. Outside the square bracket on this side, on the right side. And no, open square bracket only open square bracket. Okay, yeah. Now go outside the square bracket, outside the quote. We're just basically tidying it up. This is all eye candy. Okay. Now what we want to do is put set W, SETW, and let's say 1, 2, 3, 4, 5. Right, 5. Set open parentheses 5. Open parentheses 5. Yeah. All right. Now and then left shift again. And then here, yeah, there we go. And then no. Before that, you want to say bin min. Okay. And then yeah, a hyphen to say this is the lower end and that's a higher end. And we want to put the bin max also, right? Yeah, and then say bin max right there, and then left shift, and then close the square bracket within quotes. Oh yeah, and that's great. Okay, now that should be correct. I said, oh, I see. Now yeah, we need to go right to the top again and hash include a file called io-manip, right? And you can do that io-manip, M-A-N-I-P. Manip stands for IO manipulation. I think that's what it is. And then take vector and put it after that, because I keep the IO together and then the vector after that. Now let's go back and see if the set W is gone, error is gone. Why is it not gone? Oh, you got. Let's make sure there's no syntax. Oh, it's gone. The error is gone. This Xcode is just slow, right? It's gone. All right. Now I think about. All right. So that's it, right? Is that it? In July. Okay. All right. I think that's basically it. If you run it now, if you run it again, now you will see the bins with also the how big what each bin actually contains. Run it again. Okay, now increase the size. In fact, we can look at the output and we can also make some tidy ups there. So you can say, what is? No, I think. Yeah, put a space before the square bracket in your output. Put a square. No, the left one, because the number is stuck there, I think. And also set W6, I think. Set W6, not set W5. I think it's 6 spaces. This is a million, right? All right. Now, if you run it, it'll look slightly better. Okay. All right. So now, if you go to the very top, you see 25 bins. Oh, 16 times 25 is a million. It's such a simple arithmetic operation. 16 times 25 is a million. No, well, no, 4 million, 4 million. Oh, yes, that's right. 16 times 20 is 4 million. Yeah. So it is actually 4 times 25 is, yeah, whatever. The number was 4, not 16. Because previously we went up to 1 million. Then I think we changed it to 4 million, right? So our max number is 4 million, I think, isn't it? I think our max number is 4 million. Is it 4? Yeah, it's 4 million. So, right, so that's why I got 16. So the first bin goes from 0 to whatever that number was. The first bin has 0 to 160,000, right? So each bin has 160,000 numbers in it. And the count on the right side tells you how many random numbers were in that range. Now let's do one more nice thing here. We're going to say, right, these are numbers, but let me print out some stars. Let me print out some stars to show me what, to visually see what the number is, okay? So after that, the above on line 68, hit enter. Line 68, now line 69, go, yeah, end of line 69 and hit enter. So here we can say, the number of stars is 40,000. 40,000, if we divide it by 100, you'll still get 400. That's too many stars. Let's say we divide it by 1,000, we get 40 stars. Okay, all right. So we're going to say number of stars, size t number of stars, size t number of stars. Yeah, number of stars. You can actually say num stars because we're going to be using that variable later. Just say num stars, num underscore stars. Yeah, equals num stars equals bin size divided by what was we by 1,000 by 1,000. Okay, semicolon. Right, now copy that C outline from before and put it here underneath. Right, now comment out the previous C out. We won't use that anymore, and we'll use this one. Right, now get rid of the endl. Get rid of the endl. And get rid of the left shift also. Right, semicolon right there. Enter after the semicolon. Now it's printed the number, but it hasn't gone to the next line. So what we want to do is print the number, but also print a series of stars indicating how big that number is. That's what we want to do, right? So we got the number of stars. All we need to do is for size t I equals 0, I less than num stars, I plus plus. Okay, on the next line, you're simply going to say C out a star. One of those, star or whatever you want to call, whatever you want to use. Yeah, okay, right? And semicolon. And after all of the stars have been printed out, you want to go to the next line. So on the next line, outside the for loop, you say C out endl. Right? Yeah, you can stick that with the previous. You can stick that with the for statement because it's part of the star printing line. Okay, now we want to do one more thing to make sure it looks nice. Can I see the output? Oh no, left shift before the endl. Yeah, increase the size. I want to see. All right. So why is it offset 0 and then? Oh, I see the first number. The first number is okay. So let's print the first number. How many bins do we have? Go right to the bottom. Well, everything else is okay. So up to bin 9. Okay. So where you print I says size ti. Yeah, output where. So yeah, where you print I, the C out left shift I, right? Just before left shift I, before the left shift, say set width 2. Set width 2. Left shift, set width 2. Set W2. Right now you'll see that everything. If you run it now, okay, now the output will look much nicer. I hope. Let's, I don't want to eat my words too soon. Right now, yeah, increase the size and also horizontally also. Why is it still printing too many? Hang on. Why is it still printing too many stars? 40,000 divided by 40,000 divided by 1,000 should be 40. So it should only print 40 stars. But obviously it's printing a whole lot more stars. Now go back to your code. I think there's a bug, and it's all the same. So I think our bin. All right. So yeah. num stars. Oh yeah. Num stars is not bin sized by 1,000. Num stars is bin square bracket I over 1,000. Bin square bracket I over 1,000. Okay. All right. Now, if you run this, oh, hang on. No, bins. Thank you. All right. All right. It's fixing up my errors. Okay. Thank you. All right. So if you run it now, I think it'll look much nicer. Okay. Now, yeah, increase the size. All right. This is beautiful. This is really beautiful. Oh, actually, let's make it even nicer. Put a space. Put a space after that number. After the number you've printed. Yeah, and before the stars. Before the stars. No, not there. After bins of I. After bins of I. Still something wacky about that. Oh, that number itself is being printed in variable spaces, right? So in fact, put a set W before that too. Set W before that, and let's say 6 there too. Okay, now run it. I think it'll look much nicer. Okay, yeah, make it big. Oh, why is it still? I'll see that line 6 to 7 changed. Something changed between 6 and 7. Oh, because it's 7. Oh, I see. That number inside needs to be 7. Start with 7. So not 6. Right. The middle one. No. That's 6. The middle one should be 7. The middle one should be 7. Okay. Now, famous last words. Okay. Now I think it'll look much better. Okay. Everything will be lined up. Okay, all right. Oh, well, I don't know. The first 2 are not lined up, but I'll leave that to you. Okay, you guys can figure it out and fix it. But it's just a cosmetic issue. Now, okay. So the thing that we want to appreciate here, the point that I really wanted to get to, was this. Okay, the point here is that you remember RAND generates a uniformly distributed number. Okay, generating numbers with a uniform distribution, very, very hard. Okay, because in nature, every random number you see is actually a bell-shaped curve, right? People are talking about bell curves and bell curves. It's a Gaussian distribution. It's named after Gauss, the mathematician. Every number you see in nature is actually a bell-shaped curve. That's why, in physics, when we do experiments, we plot all the data points. We actually see that thing, right? Not all the data points are exactly the same number. You actually see a curve. And then the average is what we take in our physics measurements, right? Chemistry measurement. The average is where the bell shape, the mean, actually exists. So why is this not a bell-shaped curve? It's because generating uniform random numbers is an art, right? It's very hard to generate uniform random numbers. That is why the output of RAND is so precious. Most people don't even appreciate that, right? Most people don't understand this, right? RAND is such a simple function, and it's in fact a primordial function. It's been around since Unix was invented, even long before C++, right? RAND is a function that went through enormous pains to generate a random number that is uniformly distributed. Because otherwise, if they said, in order to generate the number, I'm just going to take some random phenomena inside the computer, alpha particles hitting there and there, and I'm going to generate a number, it won't be random. Okay, I can assure you, you won't see all numbers equally. It'll be a bell-shaped curve. Now I'll show you what I mean by showing you how easy it is to destroy something so beautiful. Okay, there's so many beautiful things on Earth, right? But many times people don't realize that these beautiful things can be destroyed so easily without even thinking, right? And we're going to take this beautiful uniform distribution, which is equality, right? Uniform is equal, right? Everybody is uniform, equal. We're going to take that uniform thing and without knowing, we'll just destroy it, okay? And take it back to what you see everywhere, right? So take this valuable thing, which is uniform, and make it something that is, very common, which is a bell-shaped distribution. Everywhere you see a bell-shaped distribution, right? And we do that by leveraging what is called the central limit theorem in statistics. Now, those of you who are studying statistics on the side, you'll probably learn something called central limit theorem. And it's an incredible theorem that says no matter what distribution your numbers come from, whether it is uniform, whether it is a Poisson distribution, exponential distribution, a gamma distribution. This is because if you look at all the distributions, you have many different. You have a bell-shaped curve, that's a normal distribution. You have a curve like that. High numbers are more likely than low numbers. That's a different kind of distribution. So there are many different distributions out there. The central limit theorem says no matter what the underlying distribution is, if you take many numbers from the same distribution and add them up, it'll all become a normal distribution. Everything will become a bell-shaped curve. No matter what the sophisticated shape you have underneath, if you add them up together, that distribution is destroyed. Okay, it's become a normal distribution. And we'll do an experiment to actually see that in action, right? I bet you've never seen this experiment in any other class, even in science classes. This is how easy it is for people that don't know computer science, don't know mathematics and statistics, trying to say, I'm going to use rand and do this, and I want a bigger random number, I'm going to add these random numbers, get a bigger random number. Finished. Okay, they've basically destroyed this beautiful uniform distribution. So let's go back to the place where we generate the random numbers, right? There you go, right? Rand percent rand number max number. Okay, so here all we're going to do is we're going to add up 3 of those guys and divide by 3. Basically, we're going to say each random number of each of our random numbers is going to be the average of 3 random numbers, meaning add all those 3 and divide by 3. That's what we're going to do. So we're going to do so copy that rand percent max number, right? And actually put it in parentheses and then copy it. Right? It's much easier. Right? Put in parentheses and then copy the whole thing, right? And then space plus. Yeah, thank you. Space plus. Yeah, on the same space plus. Pasted, and then space plus pasted, right? And then put the whole thing in parentheses again. Divide by 3. Okay, now let's put a comment above the for loop. Okay, and this comment is going to say we are deliberately destroying the uniformity of the distribution below by summing random numbers so that we can see a different pattern in the output. Okay, so that's what we're going to do. Now, if you run this, right? Surprise, right? If you run this now, you will see a completely different shape because it's not uniform anymore. Right? Well, actually, let's change the number of stars per bin, okay, so that it'll look much better. What did we do? Bin size. Make that 3 times bin size, okay? No, where are you gonna say bin? No, further up, I think. Number of histogram data. Oh, wait a second. Yeah. Bin min and bin max. Oh, it's actually just the number of stars, right? The number of stars needs to be, yeah, divide by 3,000 instead of 1,000. I think that will be better. Yeah. Now you'll see that our it's taking a long time. Yeah, increase. There you go. Okay. Now, that is a normal bell-shaped curve, isn't it? That is a Gaussian distribution. Now, in fact, one time when I was working out there, we had a problem it was in advertising or some context, and then the CEO wanted ads to be distributed in some kind of a normally distributed. He didn't want a uniform distribution. He wanted a normal distribution for the rate at which ads are shown to certain people, right, or certain populations. And so, but the thing is, so in order to do that, we had to generate a Gaussian distribution. However, we can't use rand, because if you use rand, you get a normal distribution. So, I remember one of our engineers at that time spent a lot of time and effort implementing, not a lot of time and effort, but I'm pretty sure at least a couple of hours, okay, implementing what is called the Box-Mueller transformation, okay? The Box-Mueller transformation is a technique that is known to take a uniform distribution and turn that into a normal distribution, because it takes the uniform distribution and transforms it into a normal distribution. Now, there is a sophisticated mathematical procedure by which we can do that, and sometimes it's quite expensive to do that too, right? And then I showed him, well, you don't have to do this, because you have to make the ad selection in fractions of a second. So if you do this transformation calculation here, it's going to slow down the whole system. So there's an easier way to generate a random number. If all you want to do is just get a Gaussian distribution, you can normalize. You just take 3 randoms and average them, you get a normal distribution, right? Now, this is inherently so much cheaper than doing that other transformation. right? And this actually made a difference to our bottom line. The number of ads you can serve in per second is increased because the fewer calculations need to happen. Just doesn't make sense. So if in your job later on, right, you have to generate a uniform. Well, these days, I don't think it's necessary because most of the sophisticated random number libraries that you can use in C++, Java, and all, you can actually say upfront, saying, I want a random number, I want it to be from this distribution, right? So you don't even have to mess around like we did. It'll automatically generate that. But in those days, right, when you didn't have these transformations and you had to code up these transformations by hand, this was a way in which you could actually generate these distributions just by, and this is the result of the central limit theorem, right? So in math or stats, if you're doing a class in math or stats, and they're talking to you about the central limit theorem, and you can actually show the prof, right, your teacher, hey, I wrote a C++ program in my programming class to show the central limit theorem in action, right? So you can demonstrate that to all your other classmates in statistics and say, you want to see the central limit theorem? Here it is, right in front of your eyes. Take three numbers from any distribution, add them up, and you get this bell-shaped curve. So how cool is that? Right? So that is a histogram. And histogram is usually vertical like that, but we drew it like this, but it's exactly the same, isn't it? So was this a useful exercise? Because we did a whole lot of things here. Some of them are subtle, right? And we, what time is it, by the way? Oh, jeez. I'm so sorry. Okay. And I know that you guys are all here and working and you're all engaged, and Jaden is asking questions and all. I have no idea. We're losing time here. So thank you all. Thank you all so much for sticking around, even to Alexis. So you saw how we coded, right? And this is actually a pretty sophisticated, I wouldn't say like super sophisticated, but not a trivial program, right? We didn't write a trivial program. And although Kate, already seems to know some programming and she's typing ahead, you don't have to, okay? There have been students before who are, brand new and cold coding, and we just walk them through, and I bet you can talk to them offline. They all felt exactly as comfortable as Kate did today, okay? No matter how much knowledge you already bring, it won't be a problem. We're all going to be here and typing together, okay? So, but it'll be a worthwhile experience for you. 5 years from now too, you'll remember the first time you coded in front of other people, okay? So that is a hugely valuable experience. So thank you so much for sticking with me and staying until the end of class. And I hope this was useful. And I'll see you guys next week. We'll talk about functions, okay? And we'll talk more about passing by reference, passing by copy, and how these things work. And in fact, maybe we can take some of the older programs and try them again too, right? In the context of functions, and see what other interesting things can bubble up. And that's about it, right? Next week, after we cover functions, that's all you need to know until the midterm. After the midterm, we'll talk about objects and classes, a completely new way of looking at things. But the thing is, that's just a programming paradigm, right? True computer science and programming, that's it. As of next week, that's all you need to know, essentially. You can build anything in the world, even today. You don't even have to know about functions, right? But without knowing functions, it'll take you a lot longer and it's more painful to build it. But with knowing functions and what you know so far, you can build massive systems, okay? Massive systems without using object-oriented languages. It'll just be, more scope for errors. But if you're a careful programmer, like Don Knuth, right? And you know exactly what you're doing, you don't need object-oriented programming. You can write even assembler, and your code will be, spick and span. It'll be clean, easily understandable. So now you have everything needed to go out there and create programs. But for next, the second half of the course onwards, we'll look at ways in which you can still create what you can already create, but do it a whole lot easier, right? With less pain. And so you can say from week 6 onwards, you can say, well, this program, which I wrote in 100 lines, now I can do it in like 10 lines because I can use this new tool, an object, which lets me do things much faster, much easier, much more succinct, right? So that is what we're going to learn from now on. All the basic skills, that's all right? Until today, we've covered all the basic skills that are needed, just functions, which we'll do next class. And then you practically set up to do really cool things, right? Did you enjoy this class, you guys? Kate, thank you. Was it all okay for you? I know it shouldn't have been overwhelming, yeah, because you were typing ahead, but was everybody else okay with the speed at which Kate was typing today? I want to make sure, right? Because if that was too fast, we can make sure that someone else comes on next time and already knows programming. We can tell them, right? Be more patient. Well, obviously Kate was very patient, but we can say, right? Watch, be patient like Kate. All right. So thank you all. and I hope to see you on Tuesday. Please get more of your classmates to attend also, because each of these classes is hugely valuable, especially if you get a chance to code. If you get a chance to code, it's going to be super duper useful. So, gear up for that mentally and say, I want to make sure that I code. What can I do to make sure that I code next time? First of all, volunteer. And second of all, feel comfortable. And there's no end to what you can do. All right, then thank you all so much. I'm very glad I got to implement this program today, the histogram program. And also, you saw this very nice bell-shaped curve. It's so beautiful, isn't it? It's a normal. Yeah, I don't know, right? Anytime you see that Gaussian curve, it actually looks beautiful. That shape itself is very nice. And I think it's something inherently satisfying about it, to me, anyway. So thank you all. I will see you on Tuesday. Happy weekend and enjoy. And keep chattering in the Reddit forums. Okay, I read it and I read everyone's answers. And so thank you. Keep it active. All right, see you on Tuesday. Bye.
Be able to, oh, she's already gone.
What happened, Tim?
I was going to speak up. I did actually fall a little bit behind on the programming. She was going pretty quick. So my code,
today?
Yeah, my code works, except that like the first line prints out 1 million and everything else prints out 0. So I wanted to comb through her code and see where I fell behind there.
I see. How about this, Tim? Rather than me telling you the answer now, obviously you can share the code and I can tell you we can debug it together. I think given the paucity of interactions on Reddit, okay, wait until Kate posts her code, right? But don't look at Kate's code, but you say, or don't even wait until Kate's code is up there. You can say you can post your code, either online GDB link or something like that. Better if it's online GDB, because people can actually click on it and actually debug the code and tell you this is what it. Post a link to online GDB and say, hey, I was trying to replicate what Kate did in class and I'm getting this issue. Can someone help me out? Okay, and that would seed it for other people to chime in, and that'll be much better. Right? And if you're not getting any help, let me know. I'll help you out.
Awesome, I appreciate it.
All right, was it useful in all in general?
Yeah, oh, definitely.
All right. Thanks. All right, I'll see you on Tuesday, okay? But before that, I'll look forward to seeing your post on Reddit.
On Reddit, will do. All right.
Bye. Bye.